Hello, this is Satbi. In this video, we will learn the product rule of derivative. Product rule is a formula which calculates the derivative of the product of two functions. Here is our formula. The formula says that the derivative of the product of f and g is the product of the function f times the derivative of g plus function gx, then the derivative of the function f. So here is the one misconception among the students. They always try to calculate the derivative of the product as the product of the derivative, which is not correct. So the product rule is not this. So one thing I want to clarify this before we move on. This is a wrong formula. This is not the correct formula for calculating the derivative of the product. The product rule has an addition sign, so you can see there is only one term. So this is not what is we are expecting in a product rule. Also, you can write the product rule in a Leibniz notation, which is very helpful most of the time. So you can also write the product rule, the derivative of the first function, fx, times the second function as it is, plus the first function as it is, then the derivative dy by dx of the second function. This helps us to organize our work when we use the Leibniz notations of derivatives. Let's practice these rules on various examples. My first example is calculate the derivative of the product of product of these two functions, 5x minus 3, 7x plus 5. So if I write down the formula in terms of Leibniz notation, this will be the dy by dx, the product of derivative of 5x minus 3 times 7x plus 5 as it is, plus 5x minus 3 and the dy by dx of 7x plus 5. So as you can see that we take the derivative of one function at a time. We leave the second term as it is. We don't touch the second term. And then the first term is as it is, and we calculate the derivative of the second term. So this is the product rule. And now we calculate the derivative of 5x minus 3. The derivative of 5x 3 minus is just 5. And 7x plus 5 is as it is. And now 5x minus 3 as it is, and derivative of 7x plus 5 is just 7. I will simplify this one, but this is the complete solution here. You will get full credit till that step. So this is a 35 plus 25. If I FOIL it out, if I FOIL this out, it's going to be a 35x minus 21. So your final answer is 70x plus 4. This is our final answer. Let's take one more example. So I have two more examples on this slide also. So we will start with the example number 1 solution. So the derivative of this function f prime of x is will be calculated by the product rule, because there are two functions, x cubed plus 2x and e to the power x. So since it is the product of two functions, I must use the product rule. So this is a dy by dx of the first function, derivative of the first function, x cubed plus 2x. E to the power x will stay as it is, and then we add addition sign. This time x cubed plus 2x will stay as it is, and I will calculate the derivative of e to the power x. And then I will write down what is the derivative of 3x cubed plus 2 is will be 3x squared plus 2. It is using the power rule. e to the power x plus x cube plus 2x, and derivative of e to the power x is just e to the power x. So I will simplify this one a little bit more. So e to the power x can be pulled out. So this will be 3x squared plus 2 plus x cube plus 2x. So I pull out e to the power x because it was common in these two terms. And then let's see what inside term is. Is it 3x cube plus 3x squared plus 2x and plus 2. So this is our final answer. We will put a box around it. Okay, let's move to the next example. So next example, in that example, we will calculate the derivative of the this function. Again, you can see this is the product of two functions, x to the power of 1/2. This function can also be written as x to the power 1/2 and x cubed plus 3x plus 1. So if I write down the derivative of this one, the f prime of x, since it's a product, I will use the product rule. So dy by dx of x to the power 1/2, I will write as a power function because it will help me to use the power rule. X cubed plus 3x plus 1 as it is. And then we add a addition sign, x to the power 1/2 is as it is. And now I will calculate the derivative of the second term, which is a x cubed plus 3x plus 1. So now what we will do is we will calculate the derivative of these respective term. So x to the power 1/2, its derivative is a 1/2 x to the power negative 1/2, because if you take 1 from negative 1, it will be just negative 1/2. And then this is a x to the power 3 plus 3x plus 1. And then this is x to the power 1/2 and 3x squared plus 3, and derivative of 1 is 0. This time I will not simplify. I will just leave the answer as 1. Yeah. So you do not have to simplify when you are just calculating the derivatives. But if you need to use the derivative to find some other property of the functions, then in that situation, you do have to simplify your function. So let's move to the next problem. So I have two more problems here in this section, in this slide. So here is again is a product rule because it's the product of two function. So the derivative of this will be f prime of x, just simply dy by dx of x to the power 4 plus 1 e to the power x and x to the power 4 plus 1 times dy by dx of e to the power x. Derivative of x to the power 4 plus 1 is 4x cube. This will be multiplied to e to the power x, and derivative of e to the power x is just e to the power x, so it's the power x. I can simplify because simplification is not here too complicated, so I will do that. I will just pull out e to the power x in both the factor, and that become 4x cube x to the power 4 plus 1. And I will box my answer. Let's work on the next problem. This problem has a different variable, but that won't change anything. It is question number 4. Here we have the product of this function and that function. e to the power r. So therefore f prime of r, the product will be d over dr, r square minus 2r time er, and then r square minus 2r dy by dr of e to the power r. So derivative of the first term is 2r minus 2 e to the power r is as it is. And again, derivative of e to the power r is e to the power r. Therefore, r square minus 2r e to the power r. Since I can pull e to the power r, so I will have 2 r minus 2 plus r square minus 2r. This cancel. So our final answer is e to the power r square minus 2. Okay, next I have two more problem here where we can practice the derivative. So problem number 5. So again, the product of these two functions, so derivative f prime of x will be dy by dx of x to the power 1/2 times x square plus 1 plus x to the power 1/2 dy by dx is x square plus 1. So this is a 1/2 x to the power negative 1/2 and x square plus 1 plus x to the power 1/2. The derivative of x squared plus 1 is 2x. So very simple. So that is the complete answer. So you can box your answer here. Let's work on that another problem. So solution to that problem is as follows. F prime of x, problem number 6, is the dy by dx of x to the power 3/2 times x minus 4 e to the power x and plus x to the power 3/2 dy by dx of x minus 4 e to the power x. So now the derivative of x to the power 3/2 is a 3/2 down and you take 1 from the power. This is how you calculate the derivative of a power function by using the power rule. And x minus 4 e to the power x is as it is. And second time we will do is we will 3/2 as it is, we will take the derivative of this. Since we know the subtraction derivative of this subtraction of two function is the subtraction of this derivative. So we calculate the derivative of x, which is a 1. Derivative of the constant time function is a constant time multiplied by the derivative of the function. So 4 times derivative of e to the power x is just e to the power x. So this is a 3/2 and 3/2 minus 1 is just 1/2. This is a x minus 4 e to the power x plus x to the power 3/2 1 minus 4 e to the power x. That's completely. So I worked on 6 different examples where I use the product rule. And now I have 1 quiz questions for you. Please pause the video for 1 and 2 minutes and work on this problem. This is a product of two function. You have to use the product rule, and then you can leave your answer in the link above to compare with the other people who are working on this problem while watching this video. My next example is when I we do not have the function, but instead of that, we have a function evaluated at a specific point 1. In that situation, how you calculate the derivative of the function, which is the product of two function, and then calculate the derivative at that specific value. So here we have basically the function h of x is equal to fx times gx. If I calculate the derivative of this function, it's going to be f prime x, g of x is as it is, plus fx, the g prime of x. Now I plug x is equal to 1 into the function. So it's going to become 1 evaluated at 1, derivative of h prime. Then f prime 1, g at 1, plus f at 1, g prime 1. So now substitute these values. The value of the derivative at -1 is the -3. The value of the function at 1 is 4. The value of the function f1 is -2. And the value of the derivative at 1 is just 1. So this will become -12. That will become 2. So your answer is a -14. This is a very interesting problem. And sometimes you will see these kind of problems in your exams question. And next, I have one more problem where basically we will calculate the slope, we calculate the tangent line using the derivatives. So solution to that problem. So to find the equation of a line, so we know that the equation of the line is a y is equal to mx plus b. So any equation of a straight line is y is equal to mx plus b. So there are two components we need to find is m is the slope of the line, and b is the point y-intercept, the y-intercept. So we need to find the y-intercept and the slope in order to calculate the slope of the tangent line. So first thing is that we will calculate the point. So we can calculate the point intercept later on. So the point is x value is given 1. So if you want to calculate the y value of the function, you will just plug that x value into the function. So the slope, the tangent line is going to pass through this point. If I plug 1, is going to be 2e. So one condition is the tangent line will passes through this point. Now we will calculate the slope. The slope of the tangent line is the derivative evaluated at x value. So first we will calculate what is the derivative of the function f prime of x. Since our function is the product of two functions, so I will use the product rule. Dy by dx of 2x e to the power x plus 2x as it is, and then dy by dx of e to the power x. Therefore, this is a 2 e to the power x. This is a 2x e to the power x, because the derivative of e to the power x is just e to the power x. I can pull out e to the power x, and then this will become, I can pull out also 2. And this will become basically 1 plus x. If I plug 1, so what is the slope? Slope of the tangent line is basically when you plug 1 into the derivative, which is the x value. So this is going to become 2. So this is going to become 4e. So when I have a slope, the equation of the line, the equation of tangent line will be basically y is equal to slope, which is a 4e plus 4ex plus b. How to calculate b? Because this point, so I will do this calculation here. So since this point 1 comma 2e passes through the tangent line passes through this, it means this will satisfy the equation of the tangent line. So 2e is equal to 4e plus b. Therefore, b is equal to negative, I will basically add negative 4e on both sides, which will be negative 2e. So your equation of the tangent line is 4e x minus 2. So this is the final solution. I will box that one. This is a okay. This is all in this video, and please, if you like this video, subscribe my channel and hit the bell button so you can get the next video. Bye for now.